This is the final question number 3, and it starts off asking you to consider these points 1, 0, 0, 1, determine the 2 by 2 matrix which represents anti-clockwise rotation and the reflection in the line y equals the tangent of theta. And there's good reason why they've picked 1, 0, 0, 1, and we're asking you to consider those, because if I were to think of that, putting those into a matrix, it would look something like 1, 0, 0, 1, and which is the identity matrix. And so when they say consider these 2 points, determining the matrix that represents an anti-clockwise rotation, well, once again, we're back to looking at our formula booklet, and here we see that an anti-clockwise rotation of angle theta about the origin is represented by this matrix. So the fact is that, what matrix represents this? Well, it's going to be, for part 1, just this matrix that we have here. And I'll tell you now, they're sort of preparing you for the next few questions by having you consider this, these 2 questions. And so in part 2 then, we're asking a reflection of the line y equals the tangent theta of x, and instead of looking at the rotation, our formula booklet talks about the reflection of a line and that it's the cosine of 2 theta. Now I realize we have not talked about cosine of 2 theta and things like that, or that it represents a reflection in a line, but for the moment we're going to find out that it's not necessary. But to answer this question, what's the matrix? Well, you just need to copy down the formula booklet. And there's your 2 answers for part 1 and part 2. Question 2, or part B I should say, asks you to determine matrix A, which represents a rotation from the direction 1, 0 to the direction 1, 3. Again, a rotation, if we go back to our formula booklet, we copy this, here's what a rotation looks like, and I'm going to visualize what they're asking me. And so we have 1, 0, sort of this length, and it's rotated to the direction 1, 3. And so the thing to recognize here is the fact that this is a right triangle that we're looking at, because 1 and the 1 are vertical with each other. And so I'm looking at cosine theta, and this is the angle theta that my 1, 0 rotated up to the direction of 1, 3. And so what I can see here is now I can think, well, sine is opposite over hypotenuse, and what we just have to work out real quick, this is the length of 1, this is the height of 3, 1 squared plus 3 squared is 10, and the square root of 10 would be this length. So if I think about what is the sine of theta, well, the sine of theta is opposite over hypotenuse, and the cosine of theta is adjacent over the hypotenuse. So now if I go back and think about my matrix A, well, I now can see that A is equal to the cosine of theta, which is 1 over the square root of 10, the negative sine theta, so negative 3 square root of 10, just the sine of theta, and again, the cosine of theta. So there's my matrix A, which represents this rotation. Again, this is the way I've thought about it, worked it out, is that we've rotated, it makes a right triangle, and pretty much for all these, you can work out a right triangle and work out the ratio of opposite hypotenuse, opposite or adjacent hypotenuse to come up with your values for sine and cosine. Part C, a triangle has these vertices. It undergoes a transformation represented by the matrix A inverse XA, where X is the matrix representing the reflection of the x-axis. So find the coordinates of these vertices. So what are they really talking about? Well, first we have the vertices. So picture we have this triangle. For the moment, I'm going to call it triangle P. There's a reason why I want to give that a label. Next, we know from part B, here's our matrix A, and X being a matrix that represents a reflection in the x-axis. Well, in the x-axis, that means, if you think about it, these points here get reflected below, so our y values become opposites. So x stays the same, y becomes negative. So there's our matrix X, and then what we're really talking about is A inverse, whatever that might be, times X times A, multiply the matrix that represents the vertices of my triangle, and that multiply all that, we'll find the coordinates of the vertices of my transformed triangle. So somewhere out here is going to be a new triangle, the image of P, that when I multiply P with the inverse of X and the reflection matrix X, and then A itself, I get P's image. And when I calculate all that out, and again, I would enter this into my calculator. You can do it by hand. I did. It's a bit of work. But we come out with, here's the answer. So this is truly what my triangle should look like. So 0, 0 remained, then negative 3, 1. So I'll just try to sketch it out. Negative 1. There's a second vertice, and then negative 19/5 is almost negative 4. 1, 2, 3, almost negative 4, and that's a little more than 3. So somewhere about here is my other vertice, and so we have a triangle that looks like that as the image of P. Now, are we done? No, we're not done, because the question, and I've highlighted, it's asking about the coordinates. So what we really want to say is the coordinates are these points. And now we're done. Part D, we have a new matrix B, which represents a reflection in the line y equals mx. And they want you to find the value of m. So I mentioned before, part 1 had a formula for a reflection using the tangent of theta. But at the moment, I want to show you how we can actually work this out without going through their process. Number 1 is to know, so here's what this matrix A inverse XA actually works out to be. And 2, it says that this matrix B, which is equal to this, represents a reflection in the line y equals mx. So we must have some line that goes through the origin, and it may be going this way, it may be negative, but we have some line y equals mx that this matrix represents a reflection through that line. And so my approach to this is I'm going to pick a point and apply this matrix. And there's a point that I'm thinking of that will make life easier, and it's going to be this point 5, 0, which as a vector matrix is 5, 0. So what that means is, and the reason why I've decided to pick it is I will be multiplying it with my matrix and you can see why I chose 5 and not 1, 2, or 3, or 4, and that is when I multiply, I will get negative 4 fifths times 5, so that will be negative 4 plus 0, and then for my second row, negative 3 fifths times 5 will be negative 3 plus 0. So when I multiply this matrix times that point, its image is over here, 1, 2, 3, and 1, 2, 3. So here's its image. One thing to think about is I can connect these two, and so my line of reflection must bisect this, because if it's a reflection, this distance has to be the same as that distance. And if it is a true line of reflection, well, this will also have to be perpendicular, 90 degrees. So how does that help me? I want to know what is the slope of this line. Well, that slope, m, is going to be the negative reciprocal of this slope. So I have this slope between these 2 points where this slope will be its negative reciprocal. And so really I have rise over run. It goes, my slope of this line, it goes a rise, it's like negative 3, so up to 0, it rises 3, it runs from negative 4 over to 5, that's a distance of 9, so that's 1/3, which means the slope of my line is the negative reciprocal of that, or flip that over and make it negative 3. So what is my value of m? Negative 3.